A number cannot be raised to an even power to get a negative value. True. A number cannot be raised to 2, 4, 6, etc. to get a negative value. Not possible. We still want to read the other three. There is more than one number that can be raised to an even power to get, no. A negative number cannot be raised to an even power. Yes, it can. Negative 2 to the second power is 4. False. A negative number raised to an even power is always 0. No. No. A negative number raised to an even power, like negative 2 to the second power, is 4. So all these they're just fishing. A number cannot be raised to an even power to get a negative value. Therefore, the square root of negative 1 is not real.
Imaginary unit.
Yes, it is the imaginary unit. Okay, evaluate the following expression or state that the root is not a real number. No, because the negative 1 or the negative sign is outside of the square root. So, take the calculator, clear this, take the square root, here it is, of 256, get the answer, and by the order of operations that we studied a long time ago, multiply the answer by negative 1. Because negative 1 is not under the square root, it's waiting patiently outside. So this is negative 16. Negative 16. I took the square root of 256. I got 16. When I finished applying the power, because it's the power first, how come? The square root, we know it's a power. Then I multiply by negative 1. Now you cannot say that the answer is because negative 16 squared is 256. No, because here we have two operations. Number one operation, the most powerful one, is the square root. And once we determine the square root, we multiply by negative 1. That's how we get the negative 16. Any questions on this? Now, what would you say about this? First of all, is this a real number or not?
Not a real number.
I couldn't hear you. You said yes or no?
Yes.
Okay, let's take a look. So this is my page 7, I think, yes. So we have the square root of negative 81. Okay, good. So let's do that. You will see what happens. The calculator will say, lady, you lost your mind. We already talked about this. You already plugged in something and I gave you this answer. Why do you want me to plug it in or tell you again? So the square root of a negative number is not real. Can we still simplify it? Yes, but it's not real. It will involve the imaginary unit. So what do we do with this? We have the square root of negative 1, which can be rewritten as the square root of negative 1 multiplied by the square root of 81. What do I replace this piece by?
I.
Exactly. What do I replace this piece by?
1.
Which number I square to get 81?
9.
Exactly. So then the answer is 9i. We cannot, again, take square roots, fourth roots, sixth roots of negative numbers and get real numbers. So, part A, the expression is a real number, ta, ta, ta. The expression is not a real number. What do I pick?
E.
Thank you.
Got a question. Would this like the I, the imaginary number, would that play on like pre-calculus? Just give a basis. Like would we have to learn that pre-calculus? This ask just so I could take it as a note.
So you're talking about pre-calculus. You're planning on taking pre-calculus after this class?
Yes, ma'am.
Are you sure?
That's what I'm asking. I'm asking. That's what I'm asking you. Like, that's not the next step. You know what I'm saying? So,
I don't know. It's a very good question. Careful. It's a very good question. Depending on your major, I'm not an advisor, so only your advisor can tell you your next step. But this is not the class for you if you think you need pre-calculus after this. You may think in terms of business calculus, which is Math 230.
That's what I'm talking about. Yes. Ma'am.
Okay, but not pre-calculus. Careful. Okay. Yes, this class will be enough for you to move to Math 230, but not Math 191 or Math 151 or other combinations of pre-calculus and calculus. So yes, this is good enough for Math 230, but I don't know anything about your major. Only your advisor can advise you on that. Be careful.
That's why I asked you, because I'm a business major. I just want to make sure.
I teach also Math 230, and Math 230 we do not need the imaginary unit I.
Okay, thank you, thank God.
It's much easier than everything else. You'll see.
Yes, ma'am. Thanks.
Okay, good. So we finalize that. We clear that. Good. So back to our situation here. So evaluate expression or state expression is not a real number. So the square root of a multiplied by b, assuming these are positive numbers, can be rewritten as the square root of a multiplied by the square root of b. These are very important rules. The square root of a over b, assuming they're both positive, this is the square root of a divided by the square root of b. Please be very careful. The square root of a plus b, do not touch. Do not ever attempt this. And if you have minus, please do not. So remember these three rules, please. So if I have a square root or any index, it can be any index, and any index, it's the same property. Not necessarily the square root. It can be any, right? So, but if it's an even index, they both have to be positive. The rule does not apply if they're not positive. But for the odd indices, anything works. So the radical of a product is the product of the radicals. The radical of a ratio is the ratio of the radicals. Don't touch anything if you have a sum or a difference as the radicand. You can do anything. It's carved in stone. So the next example is the square root of 1 over 100. Both are positive. The index is even. I will use this rule. I will write the square root of 1 over the square root of 100. I will simplify the top. I will simplify the denominator. What do you think? What does the numerator simplify to? What does the denominator simplify to?
1 over 10.
That's it. Done. There's nothing else. Well done. That's all we need to do. So I just have to enter in here. The expression is a real number. And I have to enter a fraction. And I have to enter 1. And I have to enter 10. And I'm done. How would you simplify this? Can anyone quickly tell us?
7 over 5.
That's it. How will you simplify the next? You have to say,
That's what
you have to say, I will perform the operations under the radical. How much is 100 minus 36?
64.
And how much is the square of 64?
8.
That's it. I'm going to enter 8 as the final answer. I was able to perform the operations under the square root, and then I apply the square root. The cube root is always friendly. What will you say as the answer for the cube root of 8? We looked at it a few minutes ago.
2.
2. Excellent. What about the cube root of negative 27? Is it a real number or not?
It's a real number.
Yes, because
Negative, a negative is infinity, goes forever.
Because the index is
3.
odd. Correct. That's why this is a real number, because the index is odd. Okay? The same thing, you're going to take the fifth root of 243. If you like my method, you don't have to. I like 243 to the power of the fraction 1 divided by 5. That's easier for me. You don't have to. So the answer is 3. And I will enter 3. Of course, as a fraction. It's 1/3. So 1 divided by 3. Okay. I just want to make sure that you have all the information. So this is clear. Okay. The imaginary I is defined as, what do I pick? The imaginary unit I is defined as -1, 2, 3, 4.
-1.
Careful. Then it's a real number, and we know it's not.
The second option.
The second option. Therefore, I squared is
-1.
-1. Excellent. Excellent. Okay. Okay. What about, I'm sorry, 16. Sorry. What will you say? Remember, we just simplified the square root of -81. This is the same thing with the square root of -4. I have to break it up. What will you say the answer would be?
2i.
2i. Does everyone agree with 2i?
Yes.
Perfect. Excellent. Good. Let's look at 17. The same thing. Oh, no, this is not the same thing. It's a different story. Slightly different. Let's take a look. So the square root of -45, like before, I will write the square root of -1. I will write the square root of 45. Of course, you're going to say, obviously, this is the imaginary unit I. But this is not a perfect square. And remember, I can only simplify multiplication and division. Therefore, I have to change it into a product. And the product I need is 9 times 5. Why? Because 9 is a perfect square and 5 is not. So I will write one more time. I want to write it one more time as this. The square root of -1, the square root of 9 times the square root of 5. This times this times this is the square root of -45. But now I know that this changes to I. I know that this is carved in stone. And I know that this changes into
3.
That's it. I cannot write it as is. I have to rearrange it nicely. And I will write 3i the square root of 5. 3i the square root of 5. So why was this slightly more difficult? It's because 45 is not a perfect square. So when I enter the answer, I have to write 3i. I have to put the square root symbol, and I have to enter 5. Any questions on this problem before we move on? So the same thing here. You have to find two numbers. One of them is a perfect square, multiplied, factors. So one of them is a perfect square, and the other one is not. So you can simplify it. Explain why the square root of 180 is not simplified. What do you mean when you say that a square root is simplified? So, very good question. So, that's my page 8. So for the square root of 108, that's what we had, right? Let me just look again. Was it 108? I think it was, right? Yeah, 108. Okay. So the square root of 108 is not fully simplified. The square root of 3 is fully simplified. The square root of 5 is fully simplified. The square root of 16 is not fully, I'm sorry, it's just 4. I'm going to say the square root, let's say, of 18 is not fully simplified. Why? Because this is the square root of 9 times the square root of 2. 9 times 2, 9 is a perfect square, 2 is not. So this will be 3, the square root of 2. So this is not fully simplified till we take all possible integers out. Okay, I don't know what this 108 means, but I know this. 108 is, first of all, divisible by 2. Why? Because it's an even number. So 108 divided by 2 is 54. 2 times 4 is 8, 2 times 10, 2 times 5 is 10. 54 is also divisible by 2. So I have 2 times 27. But 27 is 2 times 2 times 3 times 3 times 3. What did I just do? I presented the prime numbers, prime factorization of 108. I broke it down into prime numbers. So this is basically, jump over this, 2 squared, 3 to the third. But I know now how to rewrite 108. 4 times 9 times 3. So this is the square root of 4 times 9 times 3. Why did I choose that? This is a perfect square, this is a perfect square, and this one isn't. So the square root of 4 times the square root of 9 times the square root of 3. This is 2. This is 3. So I have 6, the square root of 3. Now I can tell that this number is fully simplified because the square root of 3 is fully simplified. And there are no more powers. 2 squared with the square root is 2. 3 squared with the square root is 3 here. So let me just write this so it's not confusing. So this is fully simplified. The radical is now fully simplified. So the square root of 108 is not simplified because 108 is not prime and can be factored. A square root is simplified only when its radicand is prime. The radicand is a prime number. Sometimes, however, I'm thinking for a second, can I have a radicand that is not prime? Can I have a radicand that is, yes, I can have a radicand that is not prime. So this is a trap. So I can have a radical that is not prime. The square root of 6 is not a prime number. 6 is not a prime number. But this is fully simplified. It happened that we got, in this situation that I just gave you examples here, that we got a prime number. But that is a trap. It doesn't always happen. So we have to read the second one, or we have to read the second one no matter what. The square root of 108 is not simplified because 108 has the largest perfect square factor. Yes, in this case is 36. It has 36. 36 times 3. I broke it down even further. But it's 4 times 9, which is 36. A square root is simplified when its radicand has no factors other than 1 that are perfect squares. Correct. So here, this is a trap. The radicand may not be prime, and the radical is fully simplified. So careful with that. So here we have 36, and we check, and it's correct. So careful with that. Is this true? No. Why it's not true? Because we just looked at this number. The square root of 45 is 9 times 5, and the square root of 9 is not 9. The square root of 9 is 3. The statement is true? Absolutely not. The statement is false. We have to look at these two. So the integer inside the radical is incorrect. No, that's not the case. The statement is false. The integer before the radical is incorrect. Correct. So this is 3, because 9 times 5 is 45, and the square root of 9 is 3. Do we understand these ideas? Any questions? So far, any questions on radicals?